Okay, here's the second part of the video. I believe I'd already shown you the answers to these two problems, but I'll just make sure that I've talked them through clearly enough. As I'd said before, 3 times 3 plus 1 is 10. 2 times 3 minus 1 is 5. 10 divided by 5 is 2. And the second one, you should have come out with 4 as your answer. Notice the question numbers. Don't get confused by these, 24 and 25. The way I tend to create my lessons is by grabbing some sample problems from a book. Sometimes I don't think the first and the second examples are the best ones to illustrate the points that I want to make sure you've understood. Sometimes there are problems that come later in the chapter. So 24 and 25 in this case are the only ones that we talked about when we were talking about evaluating expressions. Let's move on. Combining like terms. I sure hope this is a topic that's familiar to you and that comes right back to mind from Algebra 1, but it always is worth a little bit of review. The textbook and I explain this first example, example A here, differently. That's actually a good thing. You can see this two different ways and you can decide for yourself which is the better of the two. The way the textbook explains it, 7x plus 4x, they factor the x out. They apply actually the distributive property, as they say. Now you might think of the distributive property as working in the opposite direction. You might not usually think of the distributive property as being factoring out. Depends on how it was explained to you back in Algebra 1. It might more likely seem like you would work from this side over here by distributing the x to each of these pieces. One of the things you have to get used to with algebra, particularly with Algebra 2, is that both sides of an equation are in balance with each other. Therefore, it doesn't really matter which side you have or which side you start with, because they're both the same thing. So this, going this way, is the distributive property. But so is going this way. And you are taking the x out in this case and saying you've got 7 plus 4 times x. Okay, well then, as the textbook says, 7 plus 4 becomes 11 and you've got 11x. I would have said this differently. I would have said, imagine that you've got 7 of these x things. Think of them, if you want, as coins from some foreign country. So you've got 7 of the x's and you've got another 4 of the x's. 7 of them and 4 of them. Are you allowed to combine them? Yes, you are. Why? Because you've got the same variable and the same exponent. In this case, the exponent is 1, which is not shown here. It usually isn't when it's 1. But you're allowed to combine them both as long as you have the same variable and the same exponent. So 7 of them and 4 of them make 11 of them. Example B. The textbook and I do this one the same way, pretty much. N squared, n, and n squared. Like I said, it has to be the same variable, but also the same exponent. The only case where that's true is the first term and the third term. So like the textbook does, I would have put those two together at the very beginning. 3 of the n squared things minus 1 of the n squared things. And then separately, I've got to deal with that, what was originally the middle term, the n. 3n squared minus 1 of the n squareds is 2n squared, 2n squared plus n. Now every year, whether it's Algebra 1 or Algebra 2, I have students who try to keep going. They think I've got to do something more here, but you can't. N squared is not a like term with n. You can't put them together. You can't do any more. This is the final answer for B. Let's look at C. All right, in this case, the textbook and I would probably say this differently, but one of the things that I would like you to see is what you really have is 2 of these things called x plus 1 and minus 3 of these things called x minus 4. But you can't put these together. They're not like each other. So the logical next step, the textbook does the same thing that I would have done. They say, all right, well, let's go ahead and distribute the 2, and let's go ahead and distribute the negative 3. So let's move that out of the way and see the result. 2 times x, 2x, 2 times 1, 2, negative 3 times x, negative 3x, and negative 3 times negative 4, positive 12. All right, now I can put things that are like each other together. I've got 2x, I got negative 3x. They put them side by side at first. I would have just gone right to the point of saying, all right, that's negative x. They've got 2, they've got 12. I would have immediately said 14, but they went ahead and moved them next to each other just so you could see what they were doing. Well, anyway, 2x minus 3x, negative x. 2 plus 12, 14. You have to stop here because these two terms don't have anything in common, and don't have enough in common. They're not like, and I can't say anything more than that. So that's your final answer to that one. All right, now it's your turn to try this. Both of these examples, again, I've given you questions 17 and 21. It might surprise you, but go ahead and try to figure these out. When you're ready, you can come back and hear my answer, but I'd suggest that you hit the pause button now. Okay, I'm going to assume that you've hit the pause, that you've finished the problem, and let's move ahead and see how I solved it. I distributed the 10. I also distributed the 2. So I ended up with 10x, and 10 times negative 3 is negative 30. And by distributing the 2, I got these two terms. Then I was able to put the 10x together with the negative 6x and get 4x. And if I put these two middle terms together, I got negative 20. And I had to stop. Sorry, didn't want to move on to the next problem yet. I had to stop there because the x and the negative 20 can't be combined. So that's my final answer right there. The second one, 21. All right, in this case, again, I'm going to distribute. I can't put x cubed together with x squared minus 1, and I can't put x squared minus 1 together with x plus 1. But I can distribute that too, and I can distribute the x squared. Distributing the x squared might be the most confusing part. X squared times x is x cubed, right? And x squared times 1 is x squared. So you should end up with these 5 terms. The original one that you had, x cubed, when you distributed that, you should have ended up with these 2 terms. And when you distributed the x squared, you should have ended up with these 2 terms. Now I can put the x cubeds together, and I get 2x cubed. I can put the x squared terms together, and I end up with 3x squared. And the only term that was left was the minus 2, and there's my final answer. How would you apply these lessons from chapter 1.2 in real life? Well, here's a problem where you might. Let's imagine that you start with $50 and you're going to buy something. You're asked to write an expression that shows how much you have left after buying N movies. Often the biggest challenge with a word problem is figuring out what you're being asked. I suggest that you go through step by step, figure out what you're being asked, and then what you've been told that helps you to get at that answer. What you're being asked is how much you have left. Well, I chose just to call that L for left. And how much you have left is a matter of how much you started with, in this case $50, minus how much you spent. Well, how much do you spend? You spend $15 every time you buy a movie. So this is all they're looking for. This is that expression that shows how much you have left. Actually, the expression is just this part. 50 minus 15 times n. I've made it an equation. Okay, now to solve the rest, to figure out what it is to evaluate it when n is 2, I go ahead and plug in. 2 here times 15 is 30, so I've got 50 minus 30, or in other words, $20 is the answer. If I instead bought 3 movies, then it would be 50 minus 15 times 3. Or in other words, 50 minus 45, which is $5. Okay? And here is an example of a word problem that you should be able to solve now. So when you're ready, go ahead and hit the pause button, and when you come back, I'll explain the answer. Okay, I'm going to assume that you've done that. Let me cover up and show you this in stages. Like I said, the biggest challenge is figuring out what you're being asked. In this case, there's no question mark even. So you got to read through the paragraph a couple of times to figure out what you're being asked is to write an expression for the total cost of buying the desk plate. Well, I decided that I'm being asked for cost. And the expression for that is going to be the pieces of that cost. Well, one piece is the $22 just to buy the plate itself. The other part is 6 cents for every letter that gets engraved, except that I get the first 3 letters free. So I've got 6 cents times 12 letters, right? I was asking for 15, but I only had to pay for 12 of those 15. So 15 minus 3, of course, is 12, and 12 times 6 cents is 72 cents. 72 cents plus the cost of the plate itself, $22, of course, is $22.72. Okay, that's it for this chapter. Sorry that we had to spread it across 2 videos. In general, I'll try to be quicker than this. But here's your homework for tonight, and I'll expect that you'll do these problems and come in with any questions that you have.